This is about LCM. LCM. Now, least common multiple, or LCM of two numbers, is denoted by LCM x comma y if the numbers are x and y, and LCM is the least number which is a multiple of each of the given numbers. Multiple of each of the given numbers. For instance, if we are asked to find LCM of 6 and 8, 6 and 8, as in the common method, we are supposed to find multiples of 6. Okay, multiples of 6. Multiples of 6 include 6 times 1, 6, times 2, 12, times 3, 18, 24, 30, 36, 42, 48, and it goes on. Multiples of 8. Multiples of 8 include 8 itself, 8 times 1, times 2, 16, 24, 32, 40, 48, and it goes on. So LCM is to mean the least. Okay, the least number which is a multiple of the given numbers. Now here, multiples of 6 are these numbers, multiples of 8 are this. So of the multiples, okay. Now here 24 is found to be the least because there are no 6s, there are no 12s, there are no 18s here, and there is 24. So that 24 is found to be the LCM of, okay, this is the least number we have. So LCM of 6 and 8 is simply 24, because LCM is simply the least number. Okay, so what is a possible LCM? Okay, now LCM of let's say 6 or 8, 12, and 36. Again, we have to write the multiples of 8, multiples of 12, and multiples of 36. Let's see that. Now multiples of 8 include 8, 16, 24, 32, 40, 48, now 56, 64, 72. It goes on. Now multiples of 12 include, now 12 itself, 24, 36, 48, 60, 72, 72 plus 12 is 84. Now multiples of 36 include 36, 72, now 808. It goes on. Now from the bigger one, if we find 36, okay, 36 is the first multiple because the number is 36. 36 times 1 is 36. Now here we have 36, but we don't have 36. So that 36 cannot be the LCM of 8, 12, and 36. Let's find 72. 72 here. Here we have 72. Again, here we have 72. From this point, okay, now 72 is the least multiple of 8, 12, and 36. Even though this is very long method, okay, it's better to watch out. It's better to find the common number from the bigger one. Okay, 8, 12, 36. 36 is a bigger one. So check the multiples of the bigger number in the rest of the numbers, okay, in the rest of the multiples, so that it will be short. Okay, checking then 8, 12 and other numbers. So the LCM of 8, 12 and 36 is 72. 72. This is equal to 72. But still, this is a very long and tiresome way of calculating the LCM of bigger numbers in hundreds, okay, and thousands. So that there is another method that I'm going to show you now. Okay, here we have the other method to find the LCM. This is LCM prime by prime factorization. By prime factorization. Now here in this method, we will have simple two steps. The first is prime factorizing each number. The second is form the LCM of the given numbers as a product of every factor that appear in any of the prime factorization with the largest times or with the largest power. Okay, largest times or largest power. Let's see a third example. Example 3. Now find the LCM of 72, LCM of 42 and 72. LCM of 42 and 72. Now our first step is to prime factorize each number. In our case, 42 and 72. Now 42, okay? 48. 48. Okay. Now by 2, 24. By 2, 12. By 2, 6. By 2, 3. Then by 3, 1. By 3, 1. Now, and 72. By 2, 36. Now by 2, 18. By 2, 9. By 3, 3. Then by 3, 1. 1. From this, it's possible to say, or we can have 48, which is a product of 1, 2, 3. 4 2's to the power of 4 times 3. 16 times 3, the power of 1. This is the power of 1. And 72 is equal to, how many 2's do we have? 3. Okay. To the power of 3 times 3 the power of 2. 3 the power of 2. Let's go back to the second step. The second step says form LCM of the given numbers as a product of every factor, that appear in any of the prime factorization with the largest times or power. Now here, the common one is 2 and the other one is 3, okay? So now here, 2 appears as 2 to the power of 4. Here 2 appears as 2 to the power of 3, so that this is with the largest power or largest times. So this is taken. Now 3 appears here as 3 to the power of 1, and here 3 to the power of 2. The largest power or the largest times is 3 to the power of 2. So LCM, okay, of 48 and 72 is equal to 2 to the power of 4 times 3 to the power of 2. this is simply 60 times 9. 9 times 60 is 54. 4 carry 5, 9, 144. 144 is the LCM of, okay, 144 is the LCM of 48 and 72. So by using this prime factorizing method or prime factorization method, it's possible to find the LCM of big numbers in hundreds and thousands, so that we can have 2 or more examples. Well, find the LCM of these 3 numbers, 72, 90, and 48. Let's proceed to the prime factorization. Now 72 is 72, 90, 48. This is simply by 2, 36, by 2, 18. This is by 2, 9, by 3, 3, by 3, 1. And 90 by 2, 45, by 3, 15, again by 3, 5, by 5, 1. 48 by 2, 24, 12, 12, again by 2, 6, by 2, 3, by 3, 1. So this is how we prime factorize using these 3. So 72 is equal to 1, 2, 3 to the power of 3 times 3 to the power of 2. 8 times 9 is 72. 90 is equal to 2 times 3 to the power of 2 times 5. 9 times 5 is 45, times 2 is 90. So 48 is equal to the power of 4 to the power of 4 times 3. 3. Now, this is rule number 1, prime factorizing each number. The numbers are factorized. Then the second one is forming LCM of the given numbers as a product of every factor. Do not forget this. Every factor that appear in any of the prime factorization with the largest times. Let's see the factors happen here. Let's see the factors appeared here. Now, the factors of 72 are 2 and 3 with different powers. The factors of 90 are 2, 3, 5. And the factors of 48 are 2 and 3 to the power of 4 times 3. But the basic question here is, now 2 and 3 appear as a factor in 3 of the numbers, okay? In all the 3 numbers. 5 here, it seems that 5 is not appearing here and here. But for convenience, it's possible to put 5 as a power of 0, meaning as 1 in all numbers, okay? In both, okay? Okay? Now 5 has appeared as 5 to the power of 0 in 72 and 48. Because any number the power of 0 is 1, multiplying any number by 1 doesn't affect the number, or it gives the number itself. So let's see now here 2 happens, 2 appears, 3 appears, and 5 appears. Now we are supposed to take the largest times or the largest power of each factor. Now here 2 happens, or 2 appears as 2 to the power of 4, 2 appears as 2 to the power of 1, and 2 appears as 2 to the power of 3. Now the largest one is 2 to the power of 4. Now here 3 appears as 3 to the power of 1, and 3 appears here as 3 to the power of 2, and again here as the power of 2. So this is a smaller one. Then the largest one, or the larger power, is 3 to the power of 2. Then we take one of the 3 to the power of 2s. Now, for convenience, we have taken 5, okay, 5 as 5 to the power of 0 to appear in 72 and 48, because it has happened here, it has appeared here in 90. But here 5 to the power of 0, 5 to the power of 1, and 5 to the power of 0. So that 5 to the power of 1 is the other number that appear more powerful, with more power. Then from this LCM, okay, LCM of these numbers 72, 90, and 48 is equal to the product of these powerful numbers, 2 to the power of 4 times 3 to the power of 2 times 5 to the power of 1, 5 to the power of 1, 5 to the power of 1. So this is simply 16, okay, 16 times 9 times 5. This is 720. This is equal to 720. So the LCM of these numbers is 720. 720. So this is a good way to find the LCM of numbers. I want to add you one more example, which may make you just equipable. Now this is to make you to find, okay, confident to find LCM of any number, any set of numbers. Example 6, find the LCM of 2700, 400, 4500, 7200. Now again, my advice, just pause this video, the video you are watching now, and try to factorize and set out, okay, the LCM by yourself. Then restart the video for checking, okay, for checking your answer. Now since the factorization needs very large space and time, I have factorized it, then check by yourself. Now the factors of 2700 are, okay, 2700 is equal to the product of 2 to the power of 2 times 3 to the power of 3 times 5 to the power of 2. Now 4500 can be, let's say, the prime factorization of this is 2 to the power of 2 times 3 to the power of, again, 2 times 5 to the power of 3. And 7,200, okay, 7,200 is equal to, this is 2 to the power of 5 times 3 to the power of 2 times 5 to the power of 2. Now it's possible to check by calculator by multiplying 32 with 9 and then 25. This gives 7,200. 4 times 9 times 125 is 4,500. Then 4 times 27 times again 25 is 2,700. So now from this part, now this is step 1, okay, all the 3 numbers are prime factorized. Then let's set the LCM as a product of every factor that appear in any of the prime factorization with the largest times or power. Now 2 happened, or 2 appeared here as 2 to the power of 2. 2 appeared here as 2 to the power of 2 again, and 2 appeared here as 2 to the power of 5. So the largest one is, okay. Now 3 appeared here as 3 to the power of 2. 3 appeared here as 3 to the power of 2 again, and 3 appeared here as 3 to the power of 3. Now 5 as 5 to the power of 2, 5 to the power of 3, and 5 to the power of 2. Then 5 to the power of 3 is the largest times. The largest times. So simply, the LCM of these big numbers is the product of 2 to the power of 5, 3 to the power of 3, and 5 to the power of 3. So LCM, now LCM of 2,700, 4,500, 7,200 is equal to 2 to the power of 5 times 3 to the power of 3 times 5 to the power of 3. 5 to the power of 3. Okay. Now 5 to the power of 3. This is to mean 2 to the power of 5 is 32 times 3 to the power of 3 is 27 times 5 to the power of 3 is 125. So this is a very big number, okay? Very big number. 108,000. 108,000. So the LCM of these numbers is equal to 108,000. So prime factorization is a good way, okay? Prime factorization is a good way and an easier way to solve for LCM of numbers, okay? By using the common method, the previous method, listing out the multiples. Can you imagine how many days you need to find this multiple of the 3 numbers? Thank you for watching. This is AHA Tube, okay? AHA Tube. This is our tube. AHA Tube. Your partner in maths, physics, and engineering, and other science fields. Okay, AHA Tube. Just like our tube, share our tube, so that I will get encouraged. Okay, we will get encouraged to do more, to do more videos. Thank you for watching.